basically the iron object reacts after a few months, after a few years, right? If you were to keep it in open, usually you will see it will start to react with oxygen and water, and then the color changes to this brownish color, right? So I think the reaction is not getting clear to you how this reaction is taking place and the chemical formula. Yeah, is that what is confusing?
Yes.
Okay, look here. That is quite simple here. In fact, for example, if you were to have carbon, for example, you are having coal. Coal is basically made up of carbon. So when you heat it, it reacts with oxygen now when you are heating it. So that leads to what? Formation of dioxide. Getting it? So carbon in short is represented as capital C and oxygen molecule as O2. And both of them combines to give CO2. Right. So basically in chemical terms, we have assigned symbols to each elements and compounds. So in short, carbon, we have assigned a symbol capital C to it. Oxygen, in short, we have assigned a symbol O to capital O to it. Getting it, guys? Okay. Yeah, Sundus is here or not? Yeah, Sundus?
Yes. I'm
Yeah.
him.
Mm-hmm. Okay. Is it getting clear to you?
Yes.
Okay. Now we had also devised a method to prevent rusting, right? So in the method to prevent the iron object from rusting, what we are basically doing, we are not allowing the iron object to react with oxygen and water. We don't allow the metal object to react with oxygen and water. So for that purpose, what we will do, we might apply a layer of oil over it. We might paint the iron object, or we might simply apply a layer of zinc over it.
Sir,
Yeah.
I just got disconnected, sir. So can you repeat what you were telling?
Yeah, I was telling now, in order to prevent the iron object from rusting, what are the things we can do? Whatever things we are doing, we are basically eliminating the contact of iron object from oxygen and H2O. We basically need to ensure that the iron object does not react with oxygen and water. So for that purpose, we might either apply a layer of oil over it, we might either paint it, or do galvanization. Right now, all these things we have in fact discussed in our previous class. So we might also make it in the form of alloy, react it with some other metal, or react the iron object with some other non-metal. That will lead to formation of brass. Alloy. Okay, now let's move on then. Some of the chemical changes in our every life, we talked about them as well. Respiration and photosynthesis. Right now. Then we also talked about some of the man-made chemical changes. Okay, so combustion of fuels, cleaning a tile with the help of acid, softening of hard water. You can include other examples as well. For example, burning of magnesium can also be included in this one. Burning of magnesium ribbon. Right now, guys. Okay, now let's move ahead and discuss some of the chemical changes in more detail. So here you have got a piece of magnesium strip. So magnesium strip, you guys are aware of it. Like in iron works, basically two metal objects or two steel objects are joined together by the help of a burning magnesium ribbon. Have you guys seen the how iron works are done?
No.
Basically, the process of welding, how two iron or how two steel objects are welded together. So you will see that they burn something and it gives a very bright light, a very dazzling bright light. So they are burning the magnesium strip. So take example here. This is your magnesium ribbon here. So you get a small piece of thin magnesium strip, or we can call it as magnesium ribbon also. You will basically clean its tip with sandpaper. Now bring the tip close to a candle flame. So here you have brought it close to this candle flame right now. So as soon as you start heating this magnesium ribbon, it will burn with a very bright light. Okay. So when it is fully burned, it leaves behind a very powdery ash. It gives off a powdery ash. That ash is what? It is nothing but magnesium oxide. So guys, first tell me, what is this magnesium ribbon made up of? Obviously magnesium. Right now. Here you are heating it now. We are heating the magnesium ribbon. Right. Okay. So while you are heating, the reaction that is taking place here is what? Huh, Sundus and Vaiga? Basically, this magnesium will start reacting with the oxygen now present in the air. See this
Yes, sir.
reaction here. Magnesium reacts with oxygen. Then it gives off magnesium oxide, capital MgO. So this magnesium oxide is basically the ashy powder, that the white powder that you are getting here. Getting it? So that was another example of a chemical change here. Why chemical change? Because earlier I had magnesium, but now I have got magnesium oxide after the reaction. So before you had this, now after you have got what? Magnesium oxide. So it's practically via physical methods, it's not possible to obtain magnesium back from magnesium oxide, meaning that the reaction is not reversible. Is the reaction clear to both of you? Any confusions in
Yes,
this
sir.
one?
No,
Good.
sir.
no.
Now here it says, na guys, clean its tip with sandpaper. While while we are burning it, why do we need to clean its tip with the sandpaper? What could be the reason behind this? Because over the period of time, the magnesium ribbon must have reacted with the oxygen also. Now there must have been a coat of magnesium oxide developed above it as well. Getting it? What I'm trying to say? Just like how iron rusts, just like how copper also rusts, in the same manner, this magnesium ribbon will also start to react, will also start to form a layer of magnesium oxide above it. Because because if you were to leave it in open for a long period of time, it will start to slowly react with oxygen. The reaction will be there, but it will be too slow. So that's why you need to clean it with a sandpaper, so that if there is any layer of magnesium oxide over it, it will be removed. Getting it? Is that clear?
Yes, sir.
Good.
I didn't got it.
Okay, Sundus, look what happened now. You have got this magnesium ribbon here. Yeah. Right. So if you were to leave this magnesium ribbon in open for a significant period of time, what will happen? It will also react with the oxygen, atmospheric oxygen, although the reaction will be very slow, but it will react now. Yes, Sundus? Or not?
Yes,
It will react.
it will.
Okay, so the reaction will be very slow, but still a layer of magnesium oxide will form above it. Right now, a layer of magnesium oxide will form over it. Right. So that's why we need to scrub it off with with the help of a sandpaper, so that we can burn it properly, we can heat it properly, and so that we will be able to heat magnesium directly. So the magnesium will be exposed once you have rubbed the magnesium oxide from its surface. So the magnesium will be exposed. So you can actually burn magnesium here. It will not be the magnesium oxide that will be burning. If you were to not remove, if you were to not rub it with the sandpaper, what will happen? You will be basically providing heat to magnesium oxide now. Right now,
Yes,
isn't it? How Vaiga answer on this? So now
Yes.
now when you have scrubbed it, so magnesium oxide that has been removed, So you are left with magnesium. So then it will be heated properly and it will be able to react with oxygen. Hope the reaction is clear to both of you.
Yes.
Yes,
Okay,
sir.
then let's move ahead then. Now, the white powder which you have got, which we are calling it ash, gather some of that ash and now let's mix it with some amount of water right now. So MgO plus H2O, that's what we are doing it. We are mixing it water. White powder and water. Now what will happen? We will basically first we will mix the solution very well. Here the term is aqueous solution. Why do we call it aqueous solution? Because we have added water in it. Okay, so let me write it over here. What does aqueous solution mean? A solution which consists of water in it. Okay, so you will basically mix the solution well, right? So here you will see a new substance will be formed. What will be that substance? That substance form will be magnesium hydroxide now. Magnesium hydroxide. So look over here, guys. How many reactions are taking place here? In fact, we already saw that one reaction has taken place here. One chemical reaction has already taken place here when magnesium reacted with the oxygen. Now see over here. Now you got the white powder. Now you have added water into it. Now another new product is forming here. Magnesium hydroxide is forming here. So that is also an example of what? Is it a physical change, guys? Yeah. Is it a physical change, Sundus?
It's the chemicals inside this.
Obviously chemical change because we're getting a new product here right now. So
Yes, sir.
two products can be obtained here. When you are burning it, magnesium oxide is the new substance we are getting. And when you are adding water to it, you are getting magnesium hydroxide. That is the next product when you added water to it. Is the reaction clear to both of you?
Yes.
Okay, good. Now let's take another example of a chemical reaction. This one is a, I guess you guys must have seen this or observed this or might not be. Anyways, so let's understand the reaction between copper sulfate with iron. How copper sulfate, that is CuSO4, how it reacts with iron. Okay, so in chemistry, now basically we represent elements and compounds with the help of their symbols. So iron is in the symbol of iron is capital F small e, right? So in your class 9th and 10th, you will basically get to know that metals or the elements, they have got their Latin names as well. They have derived their names from their names comes from different origin of countries. Getting it? So actually, iron, its Latin name is, its different name is ferrous as well. So in short, we have called it as Fe. Getting it? So for example, copper, it is represented as Cu only, right? Sulfate, SO4, like this. Anyways, that's a different discussion. Okay, but still you get to have an idea of how they are assigned their
Sulfate is
symbols.
FeSO4.
Which one?
Iron sulfate
Yeah,
is
iron sulfate is
FeSO4.
FeSO4. Very good. Right. So what we will do, we will take a teaspoon of copper sulfate in about half a cup of water in a glass tumbler, or let's say beaker. So that we have taken here. Now what we will do, we will add few drops of dilute sulfuric acid to it. So next you are adding some amount of dilute sulfuric acid to it. Dilute means what? You have added dilute sulfuric acid. Dilute basically means weaker acid here. So if you have got a strong base or a strong acid, that can be weakened by adding water into it,
Water.
right? Okay, but normally we do add acids into water, not water into acid. Okay, basically increasing the content of water in it. That's what we do. Okay, so you have added few drops of dilute sulfuric acid to this mixture. Now you will get that the mixture will become blue in this case here. That we can see here. The mixture has become blue now, right? Now keep a small sample of the solution in a test tube or a small glass bottle. Okay, so let's take a small sample of the solution in a test tube or a small glass bottle, so that we will be able to differentiate between the reaction that has taken place with the original color of the solution. Getting it what I'm saying? When the reaction will take place here now, the color of the solution will change, right now. So that in order to study the change in color, we will take a small sample of it in reserve. Yeah. Okay, so that we have done. Now put a nail or an old shaving blade into the remaining mixture. So we have taken a piece of iron object here that has basically rusted, right? That has rusted. So this is rusted iron over here. So that we are going to dip into this solution. Solution of what? Solution of copper sulfate and dilute sulfuric acid. And you will basically put it for 30 minutes in this. Now observe the color of the mixture. Hasn't it changed over here, guys? The color of the solution has obviously changed here, right? So what can we see here? It has become greenish in color. So what observation can be made here? The color of solution changed to green. Okay. Are the points so far clear to you? Is the activity so far clear to both of you? Yeah, Sundus and Vaiga?
Yes,
Yes.
sir.
Yeah, Sundus, what
It
about
is.
you? Okay, let me rephrase the activity. What basically happens here? Look here. You have got a beaker, right? You have taken some copper sulfate in it, and you have taken some dilute H2SO4, that is sulfuric acid in it. So here you will get the solution, and the color of the solution is blue. Right now, copper sulfate plus dilute H2SO4, that gives you a blue color solution. Okay. Now now what you did, you basically placed a rusted iron object into it. You have placed a rusted iron object in it. For example, in this case, we have placed a rusted iron, a blade basically. Now we observe that the color of the solution from blue, it changed to what? It changed to greenish color. Getting it?
Again.
Yes.
Anderson.
Got it?
Yes.
Okay, now let's see what is the thing we can notice here. Here we are seeing that the change which happened here, it was basically due to the reaction that took place between copper sulfate and the iron. Let's come back to this slide here. This copper sulfate and this iron, the reaction has taken place here. But what type of reaction has taken place here? Originally, we had copper sulfate solution, which was blue in color. This was copper sulfate solution, which was blue in color originally, right? Now we dipped a piece of iron into it. So what happened? CuSO4 plus iron. What happened? This iron reacted with the sulfate over here. So it formed ferrous sulfate or iron sulfate, FeSO4. Getting it here?
Yes.
Okay. And this ferrous sulfate is actually green in color. This ferrous sulfate is green in color. That is the reason why the color of the solution now has changed to greenish because of formation of iron sulfate, right? And there will be a brown deposit at the bottom of the beaker. That brown deposit will be what? Basically of copper. Where will this copper go? This copper will also remain in the same beaker now. It will be a brown deposit over here, right? So the change of the color of the solution from blue to green is because of the formation of iron sulfide. That is the new substance here. And the brown deposit on the iron nail is copper, another new substance. So look over here, guys. Look here. Look close at this. Can't you observe some changes in the color of this iron here? The blade earlier was shiny here, right? The color was different. Now it's what? The color has changed now.
Into like brownish.
Exactly.
Yes.
That is brownish here. Why? Because there is a deposition of copper over it. Copper has deposited on iron blade over here. That's what has happened. Yeah.
Okay,
Okay.
sir.
That is the new substance. The brownish deposit on the iron here was basically copper. That was another new substance formed here.
Okay,
Hope the
sir.
activity is clear to both of you. Any confusions in this one?
No, sir.
Okay. Sundus?
No.
Okay. So what you guys will do? Just explain the activity once more. So starting from you, Vaiga.
Okay,
Explain
sir.
what has happened in the slide so far. Right now, what are the things taking place in this slide?
Like take a beaker,
Mm-hmm.
pour some copper sulfate
Mm-hmm.
into the half of the beaker of water.
Mm-hmm.
Add a few drops of dilute sulfuric acid, I guess. Yeah.
Yeah.
And then uh, the color will change to blue.
Mm-hmm.
And then we have to add an iron nail.
Okay. Okay.
And then
Then. Mm-hmm.
after a few hours, like
Mm-hmm.
the color will change to green due to the iron sulfate.
Okay. Stop there. Okay. Now,
Okay, sir.
Sundus, explain. Okay. Why the color has changed and what are the reactions that has taken place in the activity?
So, what's the question?
Question is that why the color of the solution has changed to green and what reaction has taken place there?
It has the reaction is brown deposit.
Okay, a brownish deposit can be seen over the iron blade. Okay, that is a change we are seeing. Apart from that, the green color of the solution, why it has changed?
Because
Earlier the
we add
Mhm.
sulfuric acid.
No, earlier the color of the solution was blue. As we can see here, it is blue, right? But now it is green. It is green because a reaction has taken place. What reaction has taken place? The reaction has taken place between this copper sulfate solution here, okay, and this piece of iron over here. Both have reacted, and after the reaction, a new product has been formed that we call as iron sulfate, FeSO4. As you mentioned in the class, iron sulfate is FeSO4. Very good. Okay, so a new substance has formed, and it is actually green in color. This ferrous sulfate or iron sulfate, it is actually green in color. That is why the color of the solution it looks like green here. Right now, another change which we observed that the color of the this blade has also changed. It has changed to brownish now.
Yes, sir.
Why is it so?
Due
Yeah.
to the copper
Hmm.
formation of copper.
Exactly. So look once more here. Iron, that is Fe. So the product form is iron and SO4. That is sulfate got reacted, so it was FeSO4. Right now. Okay. Then also you see the copper also reacted with iron. Right. So there was a deposition of copper over the this blade here. That's why. Okay. So read the activity once more. In fact, it is given in the NCERT as well. Right. So you
Okay.
guys need to revise it properly, or otherwise you will get to forget. Okay. So the two reactions so far we have discussed. Remember the equations of both of them, the chemical equations, this one and this one as well. That will basically give you the crux of the activity, and that will help you in understanding it more properly, right? And this final reaction also, remember this one as well. Okay, is it clear, Sundus and Vaika? Okay, now
It's
you have
clear
got
for me.
another example of reaction that takes between a vinegar and baking soda, right? Okay, now here, what are the which one is the acid and which one is the base here?
Baking soda is the base, vinegar is nice.
Very good. Baking soda is the base, while vinegar is a acid. Which acid? It's a acetic acid. The name of the acid is acetic acid. Right now. So here you have taken some vinegar in a glass beaker and add just a pinch of baking soda into it. Right. So baking soda, if you were to write its chemical formula, it's NaHCO3. Okay, if you guys like, you can remember it, or it's up to your choice. You can leave it as well. Right. Okay, now we will observe that gas bubbles will start coming out of the beaker. So what we will do now, we will just close the mouth with the help of a cork, C-O-R-K, cork. Right, make a hole in this cork and take this a round tube over here, round glass tube that we have taken here. So the structure is so here you can see that in the another beaker here, it does not in fact look like a beaker. In fact, it's a test tube, guys. Right now, beaker is more wide. I know.
Yes, I guess it's a test tube.
Yeah, both of them here are test tube. So you have taken another round glass tube and made a hole in this cork, and via this hole, you have put this round tube into that, hollow tube into that. Now, in the another test tube, you will basically take lime water. Lime water is what? Basically, lemon plus water, lemon and water. So here what you will see, the bubble that is started to come out from this beaker number, from this test tube number A, it will reach the test tube number B over here, and the color of the lime water, it will start to change here, right? So first look, come back to the beaker number, come back to the test tube number A
It's
right
a
now.
mixture of the vinegar plus baking soda is the mixture of lime water. Lime water is different. Like it will like
Lime water is different, yeah. Lime water is a different thing.
vinegar or baking soda,
Look here.
right?
In the first activity, what's in the first test tube, what happened now? Vinegar plus baking soda. When you reacted both of them, what happened? It started to give off bubble. This bubble was nothing but it was actually due to the carbon dioxide formed. Right now. So the bubbles that was coming out of the beaker, it was due to the release of carbon dioxide. So the reaction between vinegar plus baking soda gives off bubble that is because of carbon dioxide formed there. Right now. So the question here of this activity is that how do we confirm that this gas which is evolving is actually carbon dioxide, right? So the thing here is that it is the property of the carbon dioxide gas that whenever it passes over lime water, it turns the lime water milky. So that is the test for carbon dioxide. So that that if you have got lime water and you pass carbon dioxide over it, the color of the lime water will change to milky color. Now further what happens? The lime water turns milky. Here via this glass tube we are putting carbon dioxide into test tube number B, and here you will see that the lime water will turn milky when carbon dioxide is passed through it due to the formation of calcium carbonate. So it has turned milky, but why is it so? Because of the formation of calcium carbonate here. Yeah. Okay, so far are the things getting clear?
Yes, sir, it's clear.
Okay, Sandus?
I don't know. I didn't get that.
Okay, look here. Let's revise it over here. In test tube number A, what happened? You have got vinegar and you have got some pinch of baking soda as well, right? You added both of them, then there was evolution of carbon dioxide gas in the form of bubbles, right? Now, in the form of bubbles. Was it not writing out here? Yeah, bubbles. So bubbles of carbon dioxide gas were coming. Okay, and there's another there's a type of water that is called as lime water. It is basically calcium hydroxide. This CaOH whole 2, it is called as lime water. Okay, now it is the property of carbon dioxide that if you have got lime water and if you were to pass carbon dioxide above it, the color of the lime water will change to milky color. Right now. Okay.
Yes.
Is the thing so far clear? Sundus?
Yes.
So far, just remember two things. First thing, that vinegar plus baking soda will give carbon dioxide. Okay. Another thing is that when carbon dioxide gas passes over lime water, the color of the lime water changes to milky color. Two things we have got, two things we know so far, right now. Okay. Now, what will happen in this activity? We will prove how the color changes to milky. How the color changes to milky. So we are passing carbon dioxide gas via this hollow tube into test tube number B here. And as soon as it enters here, these are the bubbles of carbon dioxide gas. So the color
The
of the lime
beaker
water
B,
will change to, yeah.
the beaker B already has the lime water.
It already has lime water in it. Up to here, up to this mark, there is lime water on it right now. And via this hollow tube, the carbon dioxide gas is coming into test tube number B, and the color of the lime water will start turning to milky color. Getting it? Okay.
Yeah.
In fact, in laboratory, in chemistry, this reaction is a standard test for carbon dioxide presence. So suppose you are doing reaction between two chemical compounds and a gas has evolved, but you don't know what gas has evolved. You can't inhale it. You can't do any other thing with it because it might be dangerous. So you will basically pass that gas over the lime water, and if the color changes to milky, then it is confirmed that the gas evolved in that reaction is carbon dioxide gas. Getting it, guys?
Yes, sir.
Okay. Now one more question was there, that why this color turns to milky? It was because when carbon dioxide was passed over lime water, actually there was formation of calcium carbonate, CaCO3, right? CaCO3. Got this? And there was formation of some water as well. So this calcium carbonate is actually white in color. That is the reason. Now, in our homes, usually in villages, the paint which they use, what is that paint? Guys, it is basically lime now. The paint that is used in villages, that comes in white powder. I think you guys must have seen that. In Hindi, it's called as tuna. I don't know if Vaiga, you got to heard that term or not.
No, sir, I haven't heard that word.
Okay, Sundus, what about you? Anyways, basically in villages now, they don't use expensive paints. They have got cheaper paint. That is actually called lime. Lime. Lime is what? It is simply CaO, calcium oxide. Okay. So what they basically do now, they will purchase this lime from market. They will add water in it. So it will become what? It will become CaOH whole to lime water. Lime, you add water into it, it becomes lime water. That is it here, lime water. Okay, so you will see what now. They will apply this, they will use this lime water as paint and they will apply it on their walls. And after some times, what will happen now? This lime water that they have applied on their wall, it will react with the carbon dioxide present in the atmosphere and it solids and it starts to solidify. Is, is this a bit too extra for you guys? Huh? Yes, Sundus and Vaika?
What, sir?
Okay, is the current activity which I told you, are you guys able to digest it or not? Like the
Yes, sir.
example of how they use it as a paint in their homes. Huh, Sundus?
Yes,
Is
sir.
it clear? Okay. All right. So in this activity, just remember this reaction that has taken place. That is very important.
Okay, sir.
Okay, now let's move on to next thing, crystallization. So you guys tell me, is it a chemical change or a physical change? Is it a physical change or a chemical change, guys?
Physical change.
I think it's a physical change because
It's a physical change here. Because the chemical composition is same. No new substance has formed. So the salt water, the salt, how does it comes from the seawater? That is too salty. So there is dissolved salts in it. You guys know already. Okay. So the salt that is obtained by the process of evaporation, like what the small farmers that live in the coastal area, what they do, they will basically obtain salt from the seawater by evaporating it. So they will make structures alongside the oceans and the waves that carries the water. Okay, so that water deposits into it and they will allow it to evaporate in sunlight. So when the water has evaporated, they are left with salt, but that salt is actually impure, right? And it is impure and it is contaminated and the crystals are small. So their shape are not regular. Their shape are not regular. So their shape can't be is not regular and can't be seen properly. And then you see large pure crystals can be obtained from a solution using the process of crystallization. So if you were to obtain pure salts, then you have to adopt the process of crystallization. And crystallization, it is a physical change. Why is it so? Because you, for example, you are having seawater. Okay, from it you are obtaining what? Salt. Although their state are different. This is solid. This is liquid here. But the thing is that the chemical composition is same here. Like it is also salt here, NaCl, and it also consists of salt here. Getting it? Yeah.
yes, sir.
Yeah, it is same as if you were to dissolve salt in water. Okay, so there we don't see that a chemical reaction has taken place. We say it's a physical change because after evaporation, you can obtain the salt back, right now. So this is the method which is in the crystallization method, you get pure solid crystals from an impure solid substance. Now let's see this activity here, how we basically do it. Okay, so you have got some boiling water and in this china dish, you have taken some copper sulfate solution, right? You will basically boil it for a while and then allow it to cool. So after some time, you will get copper sulfate crystals in this china dish. Yeah, seems quite simple, right? So that is the process of obtaining crystals from the impure solid or liquid state. Is this clear to both of you?
Yes, sir.
Yes.
Okay, so it is basically the technique that purifies seawater or separates crystals from impure samples, right? Now, you have got an example in which you will see that both physical and chemical changes are taking place simultaneously. So you all have seen candles, have used it. So in candle, two things happen. What are they?
One is like it will burn. The
One is
candle will
wax
smaller,
and
smaller. We
burns.
can't have like the
Mhm.
candle. We can't have it in the original form. I think that was the chemical
Mhm.
change.
Exactly, exactly, guys. So the paraffin wax here that is basically present in the candle that has burned, that has converted into vapor and evolved in and evaporated into the atmosphere that we can't get back right now. The wax that is burning here, paraffin wax, so that evaporated here, so that we can't get back. And look at the thread of the candle that has also burned to carbon, right? So that we also can't get back. So that is a chemical change. And then you have got physical change, because when the wax melt, it is still the same thing. It is still made up of paraffin, right? So burning of candle, it is a chemical change, right? Burning of candle is chemical change. In this, basically what is burning, it's better to say wax and candle thread, right? And melting of candle, we call it as physical change. Okay, so what happens? Paraffin wax change to vapors of wax, right? What else are evolved in this? Carbon dioxide gases evolve. Getting it? So these are the things taking place when you burn a candle, and melting of a candle is basically physical change, right? Because the composition remains same. Okay, now Sundus, I have got your assignment. I've taken the screenshot of one of the pages. There were a few mistakes in this one. Which question was it actually? Let me quickly say it. The first question was classify the changes involved in the following process on physical or chemical change. So you have written physical change as dissolving sugar in water, correct? Coating aluminum to make aluminum foil, digestion. No, look here. That was the wrong example here. Digestion. Digestion is not a physical change. It's a chemical change, no? Because so many enzymes are acting on the food, so many digestive juices are breaking down the food right now. So that can't be obtained back. Yeah. For example, in the stomach, HCl and mucus acts on the food now. Okay. So after they have acted on the food, food becomes into very paste-like form that is called as chyme. Is it possible to get this chyme into its original form? Obviously no. Later on, when it will pass to other digestive organs, it will also and then in that case also it will be acted by it will be greeted basically with other digestive juices. Okay, chemical changes you have given example of. Okay, that was no, again in this chemical change you wrote melting of wax. You should have written this melting of wax in the case of physical change, and this one will be here. Okay, got it, Sundus?
Yeah.
Hmm. And then again, you made another mistake in the second question. Cutting of log of wood into pieces is chemical change. Although you can't get back the tree from its wood logs, its log, but the composition has not changed here now. Earlier also it was a wood, now also it's wood. But if you were to burn it, if you were to burn the tree, right, then that will be an example of chemical change. Or if you were to burn the log of wood. Got it? Mhm. Okay. What is rust here? Okay, that you have answered. Good, guys. Okay, I have got some questions for both of you. Give a reason why freezing of water is a reversible change while burning of a candle an irreversible change. Notice the term burning of candle, not melting. Yes, Sundus and Vaiga, answer this question.
We can
Mhm.
So freezing of water is a reversible change because
we can
it
reverse
can be
by
liquid.
like liquid, yeah. And burning of candle we cannot be reversed because that like the original form cannot be back
Exactly,
in the
exactly. Because there what happened, no? In a candle, you have got its wax and you have got the thread as well, right now. So when you are burning it, the wax changes to vapor of wax, right? And it is lost into the atmosphere in this surrounding. And this is also changing into what? Carbon particles, right now? Carbon particles plus carbon dioxide gas. So that is the reason it's a irreversible change. And freezing that you also explained, guys. Good. Now state in this one which of the following pertains to chemical changes. Some of the characteristics are given here. Which of them pertains to chemical changes? If the substance retains its identity, will it be a chemical change? Mhm.
What's a
Look at the options.
I think E is the answer.
Produces one or more new substances by change in its composition. Exactly. That is the answer. Right? Vaiga, answer on this. Right. The rest, all the options, they pertain to physical change. Right now?
Yes.
Okay. So now we can conclude the difference between the two. Okay. So physical change, chemical change, the points are obviously clear to both of you, right?
yes, sir, it's
Okay.
clear.
Anything we need to revise again from the chapter? Any confusions?
No, sir.
Okay, so from today's class, let me pose some questions, right? So if I were to react, Sundar, this question is to you. If you were to react vinegar and baking soda, what do you what you will be observing? What do you observe?
Bubbles.
Bubbles.
Bubbles that carbon
Bubbles.
dioxide.
Exactly. Carbon dioxide gas comes out of it. Okay. Now, Vaiga, another question is to you. All right. So, if you were to obtain pure salt, which step will you follow? The step of evaporation or crystallization?
What's a can you repeat the question one more time?
If you were to obtain pure crystals of salt, so will you be doing evaporation or doing crystallization?
Crystallization.
Crystallization. Okay. Next question to you. Why your next question to you is name at least one of the chemical changes that takes place when magnesium ribbon is burnt. What is the and name the new substance that is formed?
Magnesium oxide.
Magnesium oxide. Okay, now next.
Magnesium plus oxygen is equal to magnesium oxide, right?
Very good. Next question is directed to you, Sundar. What if I were to add water into it? Will I be seeing a chemical change or a physical change? And what is the new product formed in both the case? If it's chemical, then name the new product, or if it's physical.
Chemical and magnesium hydroxide.
Exactly, magnesium hydroxide is formed. Very good. Okay. Now, I should be passing this gas. Question is to you, Vaiga. I should be passing this gas, carbon dioxide, over which solution so that its color changes to milky?
Carbon dioxide should be passed through lime water
Hmm. Can you name the
because
formula of lime water?
lime water like Ca
Mhm.
CaOH2 plus
Question
carbon
whole 2. Whole 2.
whole 2 plus CO2
Plus CO2.
is equal to CaCO3.
Very good. And that is what, this is what, Sundas? CaCO3, what do we call that?
Calcium carbon.
Calcium carbonate. Good. Okay, good.
So
Now
and
let's,
also water, right? H2O.
yeah, exactly. Water as well. That is also released. Good. Now let's come to the answered exercise. See if you guys have any question in any of the questions. Any problem in the questions. In the first question, you have to classify whether they are physical or chemical change that you can do, right? What does the second question says? Read the questions, Vaiga.
So what's I have to read the second question.
Yeah, second question, read the question. What does it says?
Okay.
Second
So,
option number A.
okay. Photosynthesis.
No, second number, question number second, true, false.
Okay. State whether the following statements are true or false. In case a statement is false, write the correct statement in your notebook. Cutting a log of wood into pieces is a chemical change.
Is it true?
It's false.
It's false. Okay. Next one, Sundus, what would be the answer of next one? Formation of manure from leaves is a physical change. Is that true?
That's false.
That is obviously false. Okay. Can you name the 3 most important nutrients that is present in fertilizers? Isn't it NPK, nitrogen, phosphorus, and potassium? Right. So the fertilizers that are available in the market, they basically consist of nitrogen, phosphorus, and potassium. Why they consist of this? Because these are the nutrients required by every plant in sufficient amount. Right now. Okay. Likewise, other questions are also easy. Okay. So you guys can attempt them as well. Right. So your assignment is basically going to solve these questions and remember the chemical equations which we have discussed. Remember the reactions and the chemical equations as well, right?
Yes, sir. Okay, sir.
Okay then, guys, that's it for today. We will meet in next class then with new chapter.
Thank
Okay.
you, sir. Bye.
Yeah.
Thank you.